Hello everyone and welcome to today's webinar. This is the 9th episode of our 12-part webinar series on countermeasure strategies for pedestrian safety. Today's presentation is going to just focus on the issue of lighting and lighting strategies that can be used to improve pedestrian safety. The presentation today is going to be delivered by Mike Sinecki. Mike is with Lee Engineering and we're very happy to have him here today to talk about lighting. My name is Dan Jeline, and I'll be facilitating today's webinar. I'd like to ask the attendees if you can hear me. If you could please click the hand icon located in the upper right-hand corner of the screen to let me know that you can hear me. That would be very helpful. See the hands all going up. That's great. I'm glad you can hear me. Glad you're all here today. We're excited about the presentation and look forward to the discussion as well. Before we get started with the webinar today, I just have a few housekeeping items and announcements to go through, and then we'll move on. First, I just wanted to let you know if for any reason your computer or the program freezes during the presentation, I'd ask you to please just reload the website and log back in. You will be able to rejoin the session. We will be posting, and have already posted actually, a copy of the presentation slides in PDF format on our webinar archive page. We will also be posting within 1 to 2 weeks a recording of the webinar from today. So if you want to refer back to the actual recording or share it with somebody else, you'll be able to do that. Like I mentioned, the presentation slides are available now. Once we get into the presentation, I'll send out a link to everybody so you can take a look at where those are. I'd like to note, or please note, that attendees will not be able to speak during the webinar, although you will have the ability to submit questions to me and comments using the chat function of the webinar software. You can feel free to ask questions at any time during the presentation, but we are planning to hold about 20 to 30 minutes at the end of the webinar for a discussion session with Mike. Later today, you're going to be receiving a follow-up email from the UNC Highway Safety Research Center with a link that will allow you to generate a certificate of attendance for the webinar. Now, it's very important if you're attending this webinar with a group of people and you are the one who registered for the webinar, that email is going to come to your email account. So please just make sure to forward that message around to the other people who are attending with you so that they can get that information and print their own certificates of attendance for the webinar. The email is also going to contain a link to the website where we've already posted the presentation materials from today's webinar, as I mentioned. And then within 1 to 2 weeks, that page is also going to feature the video recording from the webinar today so that you can look back at that. The webinar has also been submitted to and approved by the American Planning Association for 1.5 CM credits. If you typically claim CM credits, please check the online AICP event calendar for more information about how to get those for this webinar. You can learn a lot more about PBIC webinars or check out past episodes by visiting pedbikeinfo.org/webinars. And so we're sort of on the home stretch here for this particular webinar series on countermeasure strategies for pedestrian safety. Many of you have attended the previous sessions or episodes that we've delivered. I just wanted to show you some of the upcoming episodes. If you're available this Thursday, we'll be talking about traffic calming strategies. And then in January, we'll be hitting roundabouts and then also transit topics as well. So there's still plenty of opportunities to sign up for these webinars and attend those. And then again, all the episodes that have already happened, if you missed them, you can go to our website. The link is at the bottom here, and view all the video recordings from those sessions. Before we go too much further with the webinar today, I just wanted to take a quick poll of the audience. We're interested in finding out about how many people are attending the webinar from each of your sites. So if you could just take, I think maybe just 45 seconds or so to cast your vote in this poll. It's pretty quick. We're really interested in finding out if it's just you attending the webinar, if you have a small group with you, or a larger group, maybe 8 or more in your room with you. So if you can provide that information to us, we'll go ahead and gather input for just a little bit longer, and then we'll move on with the presentation after that. So just about probably 10 more seconds on the poll. If you could cast your vote, we'd very much appreciate it. Okay. All right. Well, great. We've got a lot of good feedback, so I'm going to go ahead and close the poll now. Thanks for sharing that information with us. Without too much more delay, I'd like to go ahead and turn things over to Mike Sinecki. Mike, when you see the alert come across your screen, please go ahead and take over control and and start your presentation.
Okay, very good. Now, can you see the presentation, or do you see it in the other mode?
I see it in the note mode. If you could switch the display settings over.
Okay, I think I did it by doing this.
Yep.
Swap the display. Okay, I'm going to go back to the beginning. Okay, very good. As Dan said, my name is Mike Sinecki, and I'm a project engineer for Lee Engineering in Phoenix, Arizona. I formerly worked for the City of Phoenix for 26 years as a traffic engineering supervisor in the Traffic Operations Division of the Street Transportation Department. Give you some of my background with respect to lighting and lighting experience. During my more than quarter century with Phoenix, I saw the city first purchase all of the street lighting equipment, the poles, the lights, the mast arms, from the two power companies that work in our region. I observed the conversion from originally when I came in, everything was mercury vapor street lights, to high pressure sodium with 90-degree cutoffs to minimize light pollution to the observatories that we have in the state. Most notably Kitt Peak Observatory west of Tucson, and Lowell Observatory in Flagstaff, which is north of this area. Currently, the light program is undergoing another major transition to all LED lighting, with an ultimate goal of converting the entire system to LED lights citywide. And I'm watching this transition occur in other cities as well that I visit and I speak with. Getting some more background, during the 1970s, I think some people will still remember the time of the Arab oil embargo, where many subdivision developments were done without mid-block street lighting to save on cost, to save on energy. And the standard practice was only to install single-sided lighting on many of the wide arterial streets. The entire time I was with Phoenix, there had been ongoing retrofit efforts to install the mid-block lighting that wasn't installed in the 70s and sometimes earlier, and along other facilities such as schools and churches that attract a lot of pedestrians and attract pedestrians during the hours of darkness. Now there's also a desire to go back and retrofit all the arterial streets that have only the single-sided lighting to double-sided lighting. While I was never in charge of the entire lighting system for Phoenix, once it was purchased by the city, for my last 4 years, I was in charge of the traffic signals system that installed and maintained all of the street lights on the traffic signal poles. Since my retirement, the entire lighting section has been moved over to the traffic signal shop now as a part of the street lighting section is in the traffic signal shop, with the maintenance and monitoring being performed by vendors under contract with the city. During my time with Phoenix, the city also learned that to make the downtown more inviting to visitors, more lighting, and in particular pedestrian level lighting, had to be provided in the downtown and other commercial areas to make people feel safe and secure and to make the areas more inviting. Pedestrian lighting was provided along with streetscape projects that narrowed many of the downtown streets to make them more pedestrian friendly. During this time, the downtown was transformed with the addition of a downtown baseball stadium, a basketball arena, the quadrupling of the convention center in the downtown, and the addition of light rail and several other major developments, including now we have a downtown campus of ASU, all helping to make the downtown area a much more pedestrian-friendly environment during nighttime conditions. When I first arrived, it was rare to see anyone in downtown and at night or on weekends, and now it is very typical to see large numbers of people in the downtown at night, especially during event times. The one thing about street lighting, it's not covered in the manual on uniform traffic control devices, except there is some mention of street lighting in Part 6 of temporary traffic control. Street lighting is not required unless an individual agency has a policy to provide lighting. Some agencies do not have policies or requirements to provide street lights, especially in the rural areas. However, street lighting can be a powerful tool to improve nighttime traffic safety, and in particular nighttime pedestrian safety. There are several important considerations for making sure that lighting promotes optimal nighttime pedestrian conditions. Not only are street lights a concern for the roadway, but pedestrian level lighting is also a major issue for walking along sidewalks and along trails. In addition to traffic safety, lighting contributes to personal security and helps to encourage more walking while reducing crime and vandalism in the community. And before I get into the rest of the presentation, I was provided a list of questions that individuals asked as they were signing up. Several of these questions will be addressed during the presentation, and you may have others that I will attempt to address the best I can. Go on to the next slide. First, let's talk about some of the cost modification factors that, the crash modification factors from the CMF clearinghouse. The ELVIC and VA, the Handbook of Road Safety Measures, which was done in the United Kingdom in 2004, documented a study that compared intersections with and without lighting that resulted in crash reduction factors of 38% for all nighttime crashes and a 42% crash reduction factor for nighttime vehicle pedestrian crashes. This study had a 4-star rating, meaning it's very, very reliable. The study did not specify the area type, rural versus urban, or evaluate the impact of various lighting levels on pedestrian nighttime safety. And looking through the crash modification clearinghouse, there really were no studies that provided a CMF for highway lighting along corridors for pedestrian crashes in urban areas with star ratings. So anything along segments is just pretty much the intersections. Now, there's no crash reduction factors for lighting upgrades to go from a partially lit to a fully lit areas, and there were no crash reduction factors for pedestrian level lighting that was provided. Another study done by Yi conducted a study of lighting at rural intersections in Georgia and found a 44% reduction in nighttime vehicle pedestrian crashes with intersection illumination, again comparing non-illuminated conditions to fully illuminated conditions in rural areas, and found a 44% reduction in vehicle pedestrian crashes. Much of the information in this presentation is from the August 2012 FHWA Lighting Handbook. This handbook is an update to the 1978 FHWA Lighting Handbook as well as the 1983 addendum. It is meant to provide guidance to designers and state, city, and town officials concerning the application of roadway lighting. Supplementing and referring to other resources developed by AASHTO, IES, and the CIE, this document contains information on policy and guidance, discussing references, policy, and recommendation used by the Federal Highway Administration in evaluating and administrating funds for roadway and street lighting projects, basic terms and concepts, discussing descriptions of significant terms and concepts used in roadway and street lighting projects, warranting criteria, including various warranting methods available when considering lighting, and a lot of the warranting the methods that were developed were based on the Transportation Association of Canada, the TAC that had developed some warrants for lighting. Lighting impacts, discussing various impacts, both positive and negative, of lighting systems and the ways to control and mitigate some of the negative issues. Application considerations, supplementing information provided in the reference documents, and other systems and issues discussing additional lighting and non-lighting elements. This guide is not intended to be a detailed design guide. It is primarily a resource for policymakers and the design and construction community to evaluate potential need, benefits, and applicable resources when considering a roadway or street lighting system. Documents available from organizations such as the American Association of State Highway Transportation Officials, the Illuminating Engineering Society, and others offer recommendations on lighting levels, lighting configurations, and other considerations. Now, why is the need for nighttime lighting? Driving or walking on or across a roadway is less safe in darkness than in the lighted area during the daytime due to the reduced visibility hazards for pedestrians. Though the number of fatal crashes occurring in daylight is about the same as those that occur during nighttime conditions, only 25% of the vehicle miles traveled occur during at night. Thus, the nighttime fatality rate is about 3 times the daytime rate, as illustrated in the figure in the slide. First, we need to talk about some terms that are important to know. The first one is illuminance, which is the amount of light that falls onto a surface. Illuminance is measured as the amount of lumens per unit area, either in foot candles, lumens per square foot, or in lux, lumens per square meter. Illuminance is variable by the square of the distance from the source. As a lighting metric, illuminance is simple to calculate and measure, not needing to take into account the reflective properties of the roadway surface, and only requiring a fairly inexpensive illuminance meter for field verification. The drawback to this metric is that the amount of luminous flux reaching a surface is not often indicative of how bright a surface will be or how well a person can see. Another important term is contrast. Contrast is the difference between the visual appearance of an object of interest and the visual background against which that object is observed, and the contrast is the basis of the object's visibility. From the FHWA Lighting Handbook, objects are seen by contrast, which is basically the visible difference between the object and its background. From a luminance perspective, an object that is darker than its background will be seen by negative contrast, and an object that is sufficiently brighter than its background will be seen by positive contrast. Fundamentally, a crosswalk lighting designer's task is to maximize the contrast between pedestrians on or near the crosswalk and the visual background behind those pedestrians from the perspective of approaching drivers. Several factors affect the luminance contrast between pedestrians and their visual backgrounds, such as fixed roadway lighting, headlamp lighting, pedestrian clothing, and the characteristics of the visual backgrounds. Of these, only roadway lighting can be controlled by lighting designers. Headlamps are determined by the vehicle manufacturers, clothing is chosen by the pedestrians, and the objects and spaces that make up the visual background for drivers approaching a crosswalk are generally static and are typically provided by the adjacent property owners. The lighting designer must react to but cannot change these other basic characteristics. Another issue regarding contrast is overhead road lighting installed at crosswalk generally provides greater visibility distance than vehicle headlamps alone to illuminate a scene. The effectiveness of overhead lighting in increasing visibility distance by decreasing luminance contrast is a function of several variables: the location and orientation of the luminaire, the intensity of the emitted light, and the color of the light source. This example shows the difference in luminance contrast from just the color of the light source, where you can see distinctive colors better on the photograph on the left than on the right. Another term, another important metric is vertical illuminance. Vertical illuminance is defined as the illuminance on a vertical surface. The vertical illuminance on a pedestrian is the luminance intensity emitted by the luminaire in the direction of the pedestrian times the cosine of the angle between the direction of propagation and a horizontal line parallel to the road surface divided by the distance between the luminaire and the pedestrian. It may sound complicated, but it really means the lighting in front or on the front of the pedestrian as opposed to the lighting of the top of the head of a pedestrian. You're much more visible, you're seen by the lighting on the front of the pedestrian than overhead lighting. And just a word about pedestrian level lighting. Much of this information comes from the city of Seattle that was used in this presentation. Seattle defines pedestrian lighting as any lighting source that provides lighting for public pathways and gathering areas, specifically sidewalks, pedestrian crossings, trails, and stairs. Pedestrian lighting is different than roadway lighting and has multiple purposes, including helping pedestrians to safely navigate sidewalks and pathways, providing for visibility and security at all hours, extending the hours that a business district is active, encouraging walking as a part of an active lifestyle, and improving access to transit and other services. The City of Seattle currently sets standards for light levels on arterial streets. These requirements are typically met for the use of 25-foot or higher overhead streetlights that place the light source over the roadway. This provides sufficient lighting for motorists and other users of the roadway to navigate and avoid obstacles, but sometimes it is insufficient for specialized needs of the pedestrians on the sidewalks and walkways. The definition of pedestrian lighting is restricted to light sources that are, in addition to roadway lighting, specifically used to address the pedestrian lighting needs. And these are typically 20-foot high or less, or 18-foot high on non-arterials from the surface to be lit. Now we're going to go back into discussing roadway lighting, and then we'll kind of tie these two back in later on. The first, again, from the FHWA Lighting Handbook, the lighting industry has defined standard pole spacing layout designations for roadway lighting. These standard pole spacing layout designations are one-sided lighting, opposite-sided lighting, staggered lighting, and median lighting. One-sided lighting is typically used on roadways with 1 to 3 lanes. Staggered spacing is typically used on roadways with 3 to 6 lanes. And opposite-side spacing is typically used on roadways with 5 or more lanes. Median lighting is typically used where the median is wide enough to accommodate poles and the median width meets the clear zone requirements, or where the poles are protected by barriers. From a capital cost perspective, median lighting may be very cost-effective as the number of poles required may be reduced by 50% as opposed to the opposite side lighting. However, median lighting may cost more to maintain. Median light standards may be more prone to crashes and may require more barricading for relamping if the relamping vehicle has to be in a moving lane. Median lighting also moves the lighting further away from the pedestrian walking areas and is more likely to need to be supplemented by pedestrian level lighting. To lay out poles, a designer must undertake lighting calculations to define optimal pole spacing. Once maximum pole spacing is defined, one can lay out poles on the road drawings using a calculator and a scaled rule. The design should lay out poles locating poles at a starting point such as cross streets, and spacing the poles evenly within the maximum pole spacing defined by the calculations as shown on the slide. The pole spacing may need to be adjusted to avoid driveways and utility conflicts. And one thing I want to point out, based on past experience, if you're going to have mid-block trail crossings or mid-block crosswalks, make sure you do coordination with the lighting and the trail crossings, or either locate the trail crossings to where the lighting is going to be. I've seen some bad examples where this just has not been done, and sometimes the trail crossings were put right in the middle of 2 separate light sources where the lighting is the least intense. When determining pole heights and luminaire wattages, the designer must consider the land use, residential, urban, downtown, commercial, industrial, and the road width. Pole height may also be limited by the reach of the service or maintenance vehicles used to maintain the lights. There's no exact formula for determining the optimal pole height and luminaire wattage for a given road. Factors such as the pole spacing, the pole layout, the luminaire photometrics, the wattage, the road geometrics, power line conflicts, lighting levels and uniformity, aesthetics, and obtrusive lighting issues are all appropriate considerations in defining optimal mounting height. In residential areas, the designer should also select pole heights and fixture wattages to reduce spill lights into those that are suitable for residential areas or to nearby homes. And many times that we have had to use shields to protect nearby homes from light spill. Determination of pole height and luminaire wattage is made using computer lighting design software to test different scenarios by a trial and adjustment process. Today's computer lighting software allows a designer to undertake calculations in minutes, thus allowing the designer to explore many more options than were practical in the past. An FHWA study looked at the effects of trees on lighting levels provided along a roadway. Trees may have a significant effect in the amount of lighting that lights the roadway and sidewalk. The left picture is in the winter where there are no leaves on the tree, and the right is in the summer, the same location fully leafed. The leaves eliminate much of the lighting provided to the sidewalk area during the summertime. A study entitled Trees, Lighting and Safety in Context-Sensitive Design provides some examples of how lighting systems should be designed to allow for the presence of trees at all stages of maturity. For example, the best design approach is to locate the luminaires outside the full growth lines of the species of trees along the roadway. When a roadway or pedestrian lighting project includes new or existing trees in close proximity to the lighting, an additional light loss factor should be included in the design to accommodate the light loss due to shading from the leaves. Insufficient research is available at this time to quantify the factor with precision, but an additional 10 to 20% of lighting is probably going to be reasonable. For the streetscape lighting layouts, typical lighting layouts shown in this figure from the FHWA Lighting Handbook for 2-lane roads pedestrian scale lighting may provide the required level of illumination for the street and the sidewalk together. However, if this does not provide the required results, for example, if the roadways are wider, pedestrian scale lighting will typically have to be supplemented with taller overhead lighting. The next option shows on a wider street, well, with roads of 4 or more lanes, pedestrian scale lighting will typically have to be supplemented with taller overhead lighting poles. The main purpose of the overhead lighting is to get the luminaires and mast arms extended over the road beyond the tree canopies to light the street. The pedestrian scale lighting will provide the illumination for the sidewalk. And this example shows the overhead lights on one side of the street supplemented with pedestrian scale lighting on both sides of the street. This example shows overhead lights on both sides of the street supplemented with pedestrian scale lights on both sides of the street. Pedestrian scale lighting may not be needed with overhead lights as long as the light falls onto the sidewalk area and is not blocked by the trees. We talk a little bit about the lamp type, the high pressure sodium versus metal halide. This, we'll be talking about it in a few minutes, may be something of the past, but we're going to go ahead and talk about it because still there are many systems out there that have just high pressure sodium and metal halide, which are the two most commonly used light sources for roadway lighting. Metal halide is better in pedestrian areas because of the color of lighting that's produced. High pressure sodium has an amber or kind of an orangish tint light, while the metal halide produces a white or bluish white light. While high pressure sodium is used for most roadway applications because of its high efficiency and long life, there are claims that metal halide may produce a better safety benefit for pedestrians because it produces better or improves the driver peripheral vision. The periphery of the eye is more sensitive to the spectral light provided by metal halide than the spectral light provided by HPS at typical roadway lighting levels. Research did not show a large difference in detection of black-clothed pedestrians under high-pressure sodium and metal halide lighting. However, pedestrians dressed in denim were detected at longer distances under metal halide lighting. The same lighting level is recommended for either metal halide or high-pressure sodium light sources. As shown in other research, metal halide sources should be considered. White light will provide a higher level of facial recognition and comfort to the users of the roadway. Similarly, a color difference between continuous roadway lighting and crosswalk lighting may help highlight the pedestrian presence of the crosswalk a little bit more. However, because of the energy savings and the maintenance savings of LEDs and the color of light produced, which is a very white light, this comparison is becoming moot as agencies are trending to go to LED lights as the cost is coming way down and the technology is improving. LED, of course, stands for light emitting diodes. Many agencies are exploring or are just converting to the use of LED lights due to the very low power use, the longer life, the lack of a warm-up time, they come on almost instantaneously, and the good color quality. Many concerns with LED lights is the high initial cost, or used to be the high initial cost of the lamp, and having a proper lamp design to eliminate heat buildup. Other issues that did exist was the amount of light that can be provided from an LED light source, or the luminous efficacy. LED technology is changing and improving rapidly, and the costs are coming way down. While LEDs may last several years longer than high-pressure sodium and mercury metal halide lights, they are sensitive to heat. For every 30 degrees above 70 degrees Fahrenheit, LEDs will lose half of their service life. This is especially an important concern in the south and southwest in the desert areas. If a photocell is not working properly, a light may be activating during the heat of the day and significantly shortening the life of the LED lamp or killing the LED lamp. However, major cities such as New York, Los Angeles, Seattle, Boston, and Phoenix all commit to convert all of their existing streetlights to LED streetlights. Information from a 2012 Illinois DOT roadway report says that at present, streetlight applications mostly involve high-intensity discharge sources such as metal halide lamps and high-pressure sodium lamps. Although high-density discharge sources such as high-pressure sodium and metal halide are energy-efficient sources with high lumen efficacy, They also have some performance drawbacks, such as low color rendering abilities, low lumen maintenance compared to LEDs, and longer time required to restrike after a power interruption. LEDs, or light-emitting diodes, are the fourth generation light source that have recently appeared as an energy-efficient solution to street lighting. LEDs have been used since the 1960s as indicator lamps in consumer products, and recent rapid advances in LED lighting technologies are making LEDs a more feasible and efficacious alternative for street lighting. As a result, the market share of LEDs is continuously increasing, and it is expected that high-power LEDs will gradually replace around 25 to 30% of the incandescent lighting applications by 2025. Now, this is a report that was written 3 years ago. I got a feeling that it's going to be much higher and much faster than that, especially if the energy prices start increasing. And by the way, I checked with some of my colleagues involved in some of the street light design projects and asked for some ballpark lighting costs for LED lights. I was told that for roadway lighting, and the cost, by the way, can vary based on part of the design of the pole, how the pole is installed, and a number of other factors. But for a typical LED roadway lighting, when you have 2 lamps per pole, expect a cost of about $5,000 to $7,000 per pole. For pedestrian level lighting, expect closer to about $3,000 to $5,000 per pole. And typically the pole costs are higher because for pedestrian level lighting, more likely than not, the desire is to go for an ornamental type pole, which increases the cost. I also asked about the cost for retrofitting existing streetlights into LEDs, and was told about $300 to $500 per fixture for installed cost is a good cost to estimate. And again, this may vary by different parts of the country. There is one caution that based on the fixtures used, it may require more poles to be placed in the roadways in some cases not. So there is some differences on that. Want to talk a little bit about adaptive lighting as a concept to consider. Adaptive lighting changes it could be the time of day or in the time of night when there's more activity. Lighting levels are typically established by applying criteria based on road classification, arterial, local, or collector, the type of pavement, pedestrian activity or conflict level. And the higher the level of pedestrian conflict, the higher the level of oops, I went touch my screen. Go back to where I was supposed to be. The higher level of lighting is recommended for when there's higher levels of pedestrian conflicts. The present design practice is to use highest pedestrian conflict activity level for an area for a segment of roadway to establish the minimum lighting levels for the portion of roadway under consideration. Once the minimum lighting level is established, the street lights have traditionally provided that same level of lighting throughout the hours of darkness, as adaptive technologies had not been available in the past. Pedestrian conflict levels do not necessarily remain constant throughout the hours of darkness, and in most instances, the numbers of pedestrians present in a given area will be reduced in the late night and early morning hours when businesses are closed. So numbers of nighttime pedestrians may also be reduced based on the day of weekday versus weekend, seasonal factors, and other predictable dynamics. During hours of reduced pedestrian conflict, the level of lighting can be reduced while meeting recommended criteria for the actual level of pedestrians then present. The amount of energy savings of an adaptive lighting technology can provide depends on the variance of the pedestrian conflict levels throughout the hours of darkness. During the hours of reduced pedestrian conflict or activity, the level of lighting provided could be reduced with reduced energy consumption to the recommended criteria for the actual level of pedestrians present. An adaptive technology should not affect the distribution pattern of the luminaire. Uniformity ratios are preserved, even with reductions in the lumen output. The reduction of lighting levels on local or collector or major roads can go from a high conflict to a medium to a low, depending on the predicted pedestrian activity anticipated during the course of the evening. Typically, the light output of a luminaire and lamp deprecates over the useful life, so designers should provide an initial level of lighting higher than the minimum maintained level. This compensation is achieved by applying a lighting loss factor to a lighting design. One of the components of the lighting loss factor is lamp lumen depreciation, which is defined based on the lamp supplier's published curves at the anticipated end of the lamp life. This factor is typically 10 to 30% depending on the type of lamp. Application of an adaptive technology may allow the street light to operate in its maintained level for the entire maintenance cycle, thus reducing power input and energy savings. One would not apply the lumen depreciation to a lighting design as the adapted system would adjust the lamp output to maintain a constant illumination on the roadway. Variations of lighting is not recommended in all lighting scenarios. For example, at signalized intersections typically include pedestrian crossings. Pedestrian conflicts with vehicles are very likely at signalized intersections, and they should remain the same throughout the night. Mid-block crosswalks. The same rationale for signals applies to mid-block crosswalks. Roundabouts. Due to geometry in roundabouts and the effectiveness of fixed headlights within the roundabout circle, dimming should not be applied to these facilities. And rail crossings. Rail crossing lighting is provided for the detection of trains. It is not related to pedestrian conflict levels. Therefore, reduced lighting on off-peak periods is not recommended. With the existence of the LED lights that have the very quick light up or very short lighting times, you can use the adaptive lighting technology along trails to just light the trails when the pedestrian is present or when a pedestrian is detected or a bicyclist is detected. And that could be a very efficient system to use. And it can be done through solar power because there is not the need to provide lighting all night long on certain trails. If you ever go through a grocery store and you see the lights light up as you walk by, that's the use of LED lights in grocery stores, detecting where there's a detector to detect someone's presence, and then the light will come on as they walk by and then will turn off as they leave. I want to talk a little bit about the night sky light pollution. Light pollution is a significant urban problem influencing many elements from astronomy to wildlife. And though there are existing requirements for flat lens luminaires, other minor adjustments can emit light pollution. Restrictions may also be placed on lumens that are above the 90 degrees as a percentage of the total lumens that can limit overall light levels. This is a diagram from a study that was done by the New Zealand Transport Agency. The potential for pedestrian lighting design to produce spill light should be assessed both within the lit area and more broadly outside the subject area. Physical measures and careful consideration through the design of a pedestrian lighting scheme can restrict glare and spill light. For example, luminaires should be positioned and aimed to minimize the incidence of bright light shining straight into a person's field of view. Luminaire mounting heights need to be carefully considered for all likely users of a lit space. For instance, some areas lit for pedestrians are also used by buses or delivery trucks. While a low luminaire mounting height may provide good lighting for pedestrians' needs, it could create glare for drivers of the higher profile vehicles. Bright sources of light can be replaced with a larger number of weaker sources to reduce the glare levels but still provide the same overall level of illumination. Interaction with glossy surfaces creating reflected glare should be avoided. Luminaire fittings can be selected to control the distribution of light, as this figure illustrates. Different luminaires control the maximum angle between the central perpendicular axis of illumination and the extent to which the illumination from the luminaire is visible. Luminaires recommended for pedestrian area should be assessed in terms of the angles of illumination they permit and the resultant extent of the glare or unwanted spill light. As an aside, the 90-degree cutoff, which many agencies have gone to, has resulted in some cases into spotlighting and provides less light uniformity and consistency on the road, and may require, as a result, more frequent light pole spacing or light sources. Let's go into talk a little bit about lighting crosswalks, and the first the issue of discussion is the luminaire placement. Many agencies have historically installed a single luminaire directly over the crosswalk, as shown in the upper figure. While this provides a high pavement luminance at the crosswalk, it does not adequately illuminate the pedestrian. Remember, we talked earlier about the vertical luminance lighting the front of the pedestrian from the approaching driver. The luminaires should be located so that the vertical illumination on the pedestrian makes them visible to a driver at a sufficient distance. Based on the assessments performed to select the luminaire should be located so that it provides about 20 vertical lux, or about 20-foot candles, 2-foot candles at the crosswalk. To do this, the luminaire should be located at least 10 feet in advance of the crosswalk. The luminaire location shown in the lower figure shows this. Note that for roadways that have traffic traveling in both directions, particularly those without a center median, two luminaires are required, located on either side of the road and placed prior to the crosswalk from the driver's perspective. With regards to luminaire selection and designing a crosswalk lighting systems, selecting an appropriate luminaire and luminaire height is critical. And as I said earlier, though, most agencies are now trending to go to LED lights. Since the object of the interest is vertical, the intensity distribution should have a horizontal component. If all the light from the luminaire is directed downward, the vertical profile of the pedestrian will not be adequately illuminated. The luminous intensity distribution from the luminaire must be able to provide the required luminous intensity in the geometry required. If the luminaire cannot produce the required intensity, it is not suitable for use at a crosswalk installation. With respect to luminaire height, the suitability of a luminaire can be determined using a lighting design program. And on this figure, a 250-watt high-pressure sodium luminaire mounted at the height of 28 feet shows the vertical illuminance calculated on a grid point across the road and downstream from the luminaire. The results are illustrated using ISO-illuminance plot on a plan view of the road. The two vertical lines indicate the desired vertical illuminance of 20 lux, or 2-foot candles, may be found for the crosswalk, located at a distance about 14 to 20 foot from the luminaire position. The same luminaire used at a different height may not be suitable. In this figure, the same luminaire is mounted at the height of 33 feet, when the other example was 28 feet from the road surface. As a result, the vertical luminance levels do not reach the desired level of 20 lux. Now, talking about crosswalks at intersections. Most crosswalks are co-located with intersections. Because of various constraints, the present research was limited to evaluating the lighting levels that allow detection of pedestrians in mid-block crosswalks. Although no specific research has been performed that addresses the higher background luminance typically found at the intersections and the greater cognitive demands on drivers as they approach the intersection, a level of 30 vertical lux is considered a conservative estimate on the lighting levels required for adequate visibility. The ANSI and the IESNA RP-8 recommends that lighting at intersections of roads with continuous roadway lighting should equal the sum of the light levels for each separate road. This results in a higher background luminance for a crosswalk on the approach side of the intersection. The crosswalk closest to the driver as they enter the intersection. Then the background luminance for the other crosswalks in the intersection. For the approach side crosswalks, a higher lighting level should be considered to mitigate the impact of background luminance on contrast. This means that in a two-road intersection with crosswalks each leg, the outer sides of the crosswalks should be illuminated to a higher level than the interior side of the same crosswalk, as shown in the figure on the right. A typical intersection lighting design, in the figure on the left, the lumens are positioned to provide the higher level of the pavement illuminance in this intersection and to the light potential and to light the potential conflicts areas for the vehicles. The design on the left side, the design lights the side of the pedestrians facing the intersection and does not light the side of the pedestrians facing the approaching vehicles. In order to provide a positive contrast of the pedestrians, the luminaire should be located away from the intersection to provide light on the approach side of the pedestrian, as shown in the figure on the right. Pedestrian-related crashes are a common cause of roadway fatality, and reduced visibility at night is a probable contributor to pedestrian injuries and death. The purpose of crosswalk illumination, of a crosswalk illumination study, where this information came from, was to systematically evaluate different approaches to lighting at pedestrian crosswalks to improve pedestrian visibility and detection. The project team in this study conducted a series of photometrically accurate lighting simulations in order to assess the visual conditions resulting from different light configurations and assess the economics, the initial costs, the electricity, and the maintenance costs of each system evaluated. Finally, the most promising light configuration was field tested during a one-night demonstration at an intersection in New Jersey. The results of the visual performance and the economic evaluation converged in that they suggested that a bollard-based fluorescent lighting system mounted at the ends of the crosswalk and oriented to provide vertical illuminance on pedestrians in the crosswalk could be feasible. It could be a feasible approach with reduced cost to improving pedestrian visibility. The results of the field demonstration also confirmed that the bollard-based solution was practical. Bollard-based fluorescent lighting systems mounted at the ends of the crosswalk, as shown in this diagram, or to provide vertical illumination of the pedestrians in the crosswalk, could be a feasible approach with reduced cost to improving pedestrian visibility at the crosswalks and making the pedestrians more visible to drivers. This test in Aspen, Colorado used some strong 3M light guide technologies to very effectively take advantage of new LED sources. A special new crosswalk bollard light has been developed for uncontrolled intersections. This light provides very good high contrast visibility with low glare. These light systems offer a good alternative to the typical expensive approach to completely signalize the intersection. A demonstration project was conducted in Aspen, Colorado with Rensselaer Polytechnic Institute Lighting Research Center and Intrigue Lighting. And the demonstration project turned out to be a success. Now we're going to talk about some other situations that where lighting may be considered and may be provided. First is at bus stops. This information is provided from the Designing Handbook for Florida Bus Passenger Facilities. All bus stops require adequate lighting levels to increase transit customer safety. Lighting levels must be sufficient to provide customers with a sense of security while they wait for buses. Adequate lighting also enables the bus driver to see waiting passengers and to safely approach and depart from the bus stop. Some guidance from the Florida design includes the minimum lighting levels at the shelter pavement should be 2-foot candles, but overlighting should also be inviting. So you don't want too little light, or you don't want too much light. Local transit stops should be located within 30 feet of an overhead light source. Light fixtures should be visually non-obtrusive, so as to not attract the attention of vandals. Light patterns should concentrate light at shelters while minimizing overthrow of glare onto the street. For road lighting installations, light near and above the horizon should be minimized to reduce glare and visual intrusion. If pedestrian paths adjacent to the transit stops are illuminated, the height of the light fixture should be appropriately scaled. And the use of specifically designed equipment that minimizes upward spread of light near or to above the horizon should be used. Some additional guidance that they provided, the fixture should be vandal resistant and durable for use of transit stops. The lamp compartment and electrical access area should be secured with recessed hex screws or equal means. If possible, electrical services should be low voltage to reduce the risk of electrical shock. Cutoff luminaires, low reflectance surfaces, and low angle spotlights can be employed to reduce light pollution to the surrounding area. And solar lighting is suggested in areas where there is currently no utility service or as a temporary measure until utilities can be established for shelter, for the shelter or the stop. Portable solar lighting may also be used when transit service is detoured during construction projects. Now words on the roundabouts. Lighting of roundabouts serves two main purposes. It provides visibility from a distance for users approaching the roundabout, and it provides visibility of the key conflict areas to improve the user's perception of the layout and the visibility of other users within the roundabout. An important lighting consideration at roundabouts is that the roundabout introduces geometry and channelization that the driver may not expect unless it is visible at all times. In addition, the effectiveness of auto headlights is limited in a roundabout due to the constrained curve radius, making the roadway lighting system very important for nighttime light, visibility of obstructions and hazards. This slide summarizes the IES recommended street illumination levels for roundabouts located in continuously illuminated streets. The exhibit also presents the roadway and pedestrian area classifications used for determining the appropriate illumination levels. Although some other documents, zoning bylaws, and agencies may define these roadways and pedestrian areas differently, the description shown in the slide should be used to determine the roundabout lighting levels. Vertical illuminance recommendations have also been developed to ensure adequate visibility for drivers approaching crosswalks with pedestrians. Based on the IES design guide for roundabout lighting, it is recommended that the average vertical illuminance for a series of points measured at 5 foot in height along the center line of the crosswalk, extending to the edge of the roadway, spaced at 1.65 feet for each driving direction, be equal to the required horizontal illuminance and uniformity for the roundabout. In discussion of some of the equipment, again, some of this stuff may be a little outdated because more communities are going to the LED type lighting. But this gives a sample of the typical illumination of equipment used at currently used at roundabouts. The illumination equipment shown in the slide can vary depending on the project and the specific jurisdiction. The appropriate agency staff and power company for a particular jurisdiction can likely provide additional guidance on the type of illumination equipment that is recommended or even required. On a discussion on the pole locations at roundabout, central versus perimeter lighting. The ability to provide adequate visibility at a roundabout is highly dependent on the illumination pole locations. Roundabout lighting can be achieved by installing lighting within the central island or around the perimeter of the intersection. The IES design guide for roundabout lighting recommends lighting be placed around the perimeter of the roundabout and at locations on the approach side of the crosswalks. Perimeter illumination provides the most optimal visibility within the key conflict areas and the visibility of circulating vehicles to vehicles approaching the roundabout. In addition, the vertical lighting levels in the crosswalks cannot be achieved unless approach lighting is used. Therefore, roundabouts with central island illumination may require additional approach lighting or may be combined with perimeter illumination to achieve the vertical lighting levels. This slide shows the distinct difference in the illumination on the central island and the circulating roadway between the central and perimeter lighting. Both illumination designs include approach lighting. The position of the lighting poles relative to the curves at the roundabout should be considered and is influenced by the speed environment and the potential. This slide summarizes some of the key advantages and disadvantages for the perimeter illumination design. I'm not going to go through them. I already discussed a number of them. The primary advantage of perimeter lighting is that the pedestrian areas around the roundabout will be well lit. The primary disadvantage is the need for more poles and potentially higher costs. This slide summarizes some of the key advantages and disadvantages for central illumination design. If central lighting is used, additional approach and typically needed for vertical lighting of the pedestrian crossing areas. We're going to talk a little bit about some special. First of all, oh my gosh, there was one of the slides that I intended to have in here wasn't in here, and I wanted to talk a little bit about monitoring and maintenance before we get into some of the specialized areas. I don't think it's in this presentation at all together, but whatever you install, you have to maintain and make sure that you have some kind of a system inside for periodically relamping or doing some periodic nighttime inspections. Also, most systems require police reports or phone calls, emails, or other types of, some agencies are even using smartphone apps to report outages to the agencies. However, there's one other type of system, and again, I don't have the slide up, it's not in this presentation, but an internal system monitoring is used by the city of Glendale, Arizona, the first in the state of Arizona, and I'm sure there are a few others throughout the country. It's somewhat of an expensive system to use, but right now, when the system is in use, the people who are monitoring the streetlight system, and the city of Glendale has 19,000 streetlights. They actually installed they got the approval for in 2007, and the project was completed in January 2008. Since then, the number of monitored streetlights has steadily increased to 9,582 in May of 2011. During this time, the number of malfunctioning streetlights dropped from about 1,000 streetlights out at any one given time to less than 100, or a half of 1%. And this it really made it the system's effective, made it much more effective to identify and make sure your streetlights are working that are in the system. So I apologize for not having that slide, but wanted to make mention of that before we go into some of these specialized fixtures. Some of the fixtures that we're going to talk about is a bollard system. Bollard systems will be for light is needed to doing at a lower level due to obstructions, tree canopies, or nearby residential buildings, where pole-mounted light would be obtrusive, and when there's a need to restrict vehicle movements and access, so the areas where vehicles don't go into. It helps to delineate walkways and roadways. Wall-mounted systems, shown in this, so this could be useful in underpasses. Lights mounted on walls are particularly useful in and around structures such as bridge, over, and underpasses, and they are also used in conjunction with retaining walls, such as on other structures as a cost-effective alternative to providing extra poles. This was example is an underbridge that was built in Phoenix, and if you notice, the lights are on day and night because of the length of the underbridge. There's an arterial street that goes over it. You'll notice there's a gap in between. That provides natural lighting. In most tunnels, if you have the opportunity, provide that natural lighting from above. It can be covered to keep the elements out, the debris and rain out of the underpass that's underneath. Handrail lighting is also a relatively new technology that provides a lighted strip integral to the underside of a handrail. It's particularly effective on bridges and other structures to provide an alternative to pole-mounted lights that can add weight and be far more intrusive during due to their mounting heights. In-ground and on-ground lighting is used for uplighting. I have to say that the in-ground lighting, probably the least effective and least supportive of the dark sky principles, should be used sparingly. But it also is going to be the highest maintenance, and is typically used for decorative light. Many times uplighting is used for trees and other areas, but it does not really provide the type of light to light the crossing areas or light other areas other than for aesthetics. And this slide lists some of the questions, if you have additional questions, some of the resources that can be used. Again, an FHWA lighting handbook. Apologize that A should be capitalized. An informational report, lighting design for mid-block crosswalks, that was also done for the FHWA. The city of Seattle has some very good pedestrian lighting plans and guidance. And there's the NCHR report 672 for roundabouts, an informational guide, second edition. Assessing transit design handbook for the Florida bus passenger facilities, which was referenced in this presentation. And the public lighting for safe and attractive pedestrian areas from the New Zealand Transport Agency, research report number 405. And the design and evaluation of effective crosswalk illumination, the final report that was done by the New Jersey Department of Transportation. With that, I believe that is the last slide in my presentation, and I think we've come upon the question and answer period.
That's right. Thanks very much, Mike. I appreciate all that. A lot of good information there. If you wouldn't mind, I'd actually like to stay on your screen while we do the Q&A, just so people can. I think there are a few slides I want to refer back to, and I think if you keep these resources up for now, people can kind of jot this down talking. We got quite a few questions, so I'll just start rolling through them, and we'll see where the discussion takes us. First off, you talked a lot about different guidelines that are out there and different spacing requirements and lumens and things like that. Is there is there sort of a set criteria for, if the agency is interested in looking at, what are the requirements, what do we need to meet, what are the, basic set of requirements that are out there for lighting? For one, does that exist? And two, can you kind of go back through that one more time, just to sort of the bare essentials?
Well, the IES are probably the best standards or the best guidance to go by. I want to try to avoid using standards because there really is no requirement. This is not like the manual on uniform traffic control devices, where the states have to adopt a manual and people have to adhere to it. But there is a lot of good guidance out there that provides guidance in there, and there are the best warrants that were developed that were referenced in the FHWA report came from the Canadian reference, and there are other agencies that may have developed their own. The one thing I have to concern you about, or to caution you about, is if you develop standards, then you have to adhere to them, or develop a policy. You'd have to adhere to it, because it could be used against you in a court of law. So it is good to create these types of standards and work towards improving lighting levels. And I think that going to what the IES has is probably the better type of guidance that they had. As we talked about in the crosswalk and the crossing areas, 2-foot candles of vertical illuminance, or 20 lux, is what's recommended for crosswalk areas.
And if cities are looking to hire consultants to kind of take a look at their lighting issues, what sort of criteria, I mean, from your experience, I guess, working in Phoenix, I mean, what sort of criteria are you looking for for someone who's going to be looking at these issues for a city? I mean, what kinds of backgrounds would you be looking for, and maybe examples of work, things like that?
You mean in terms of the consultant's abilities?
Sure.
I think that if they've done this type of work before, and what kind of experience they've had in this area before, I think, though, that most cities are going to be looking for people who are experienced in the LED technology and doing lighting. Although most consultants are moving into that area, being experts in the LEDs, because that's going to be where this country is going in the long term. Not only for reducing the energy costs, and every year when I worked with the city of Phoenix, they'd come back and said, okay, you've got to do a 10% reduction in your budget. Well, if your budget is street lighting, how do you do that? The only way you can do that is by reducing. You can either turn off lights or use a more efficient light source. And you don't want to turn off lights because of the liability concerns and the safety concerns that may be out there, as well as the concerns about how are you going to make this area more inviting for people to come at night. Whatever lighting that makes the conditions will look more like daytime is what you're going to be wanting to use. And the LEDs not only have the longer service lives and the less energy efficient, the greater energy efficiency, but it also provides the better type of light. So I see that more agencies are going towards that, especially since the technology has improved and the costs have come way down. When I was talking with one of the officials that is responsible for the Arizona Department of Transportation, he said that the biggest savings, in his opinion, was going to be the long-term maintenance costs of the lights. In other words, not having to have people go out every 2.5 years to replace the lights, and having at least 10 years worth of life, and possibly longer, depending on how good the equipment is. Okay. So I hope that answers your question somewhat.
Yeah, I think it does. I think it does. You talked a lot. You gave some guidance, Mike, on tree placement, or how to coordinate, tree placement with your street lighting, so that you're not running into issues of having the trees kind of block all the light from the sidewalk area. Are you aware of any cities or agencies that have gone through and done sort of coordinated plans to look at both their street lighting and their sort of urban forests, and kind of looking at their street trees and coordinating that together? Are there any good examples of that coordination being done?
Yeah, I don't know of any examples offhand. I can tell you plenty of bad examples that were done, not only with the tree placement with respect to lights, but tree placement with respect to overhead lines. Typically in the past, the people who are doing the lighting are different than the people who are doing the landscape design, and they really should be interconnected. There should be coordination. And the example I gave back earlier about placing lights with respect to any trail crossings, mid-block trail crossings. Again, I've seen when it hasn't been done and the issues that can occur because it's not done. So I think that I'd like to say that more agencies are doing it, and maybe somebody who is listening in can provide some example of agencies that are doing that as a common practice. But that really should be done to make the best use of your lighting, and make the best use of your power usage you're going to have along the roads.
Yeah, absolutely. We would be interested if you all are out there and you have examples of good coordinated street, tree, and lighting plans. I'd be interested to see examples of that, because I think that, Mike, that's a coordination that I think you're right. You can see a lot of examples of where it hasn't taken place, but I'd be interested to see examples of how it's being attacked kind of in a collaborative way. So if anybody has examples of good plans from that perspective, we'd be interested to see those. Mike, you talked a little bit about some issues with LEDs, with heat kind of affecting the service life of LEDs. Are you aware of any similar issues that might be faced in, or issues with cold, kind of in cold weather climates that might affect life or maintenance costs of these lights? Kind of from
no, in fact, I don't think that the LEDs are problematic in cold areas. The only thing I've seen were the LED street lights, sorry, traffic signals. The red, yellow, green traffic signals have sometimes been problematic because the LEDs themselves generate very little to no heat at all. And there's been issues that way. But as far as when you have an overhead light source and the light is down at the bottom, I don't see any issues with snow accumulating on it or something that's going to block it at all. They actually thrive in cooler temperatures, and they don't do as well in hotter temperatures. And the biggest concern is during the heat of the day in the desert areas, if a photocell is not working, causing your light to become on when it shouldn't be coming on during the hotter part of the day, that's when you're really killing your LED lamp.
Okay. And along those same lines of cold weather, you showed the example of some of the bollard lighting applications. I wonder if that's sort of a no-go in a colder environment where you're getting a lot of snow, where the snow is being cleared onto the roadside and possibly covering up some of those lighting bollards. Is that a concern?
It really might be a concern, but I'm talking about places in lots of snow. I could see in Anchorage where it was interesting when the last couple of times I visited the Anchorage, and you'll notice that the fire hydrants have these little flags attached to it. So in deep snow, you can tell where the fire hydrants exist. So yeah, you're probably not going to use a low bollard system like this in trails. And again, these are largely along trails, and it would be hoped that the trails would have snow removal on it. This is not something you would typically see along streets, but it's along the non-auto environments is where the bollard systems would be. But yeah, when you have high snow drifts, it could block the light emitting from the source, but it has to be pretty high snow.
Mike, speaking of trails, you spoke a lot of the presentation today was kind of focused on the roadway itself and kind of working pedestrian scale lighting in with roadway lighting. Do the requirements or guidelines sort of change if you're looking at lighting a trail corridor where it's just a multi-use path or some other sort of off-road facility? And if so, kind of what sort of issues would you look at differently on a trail versus if you were just looking at the street in general?
Well, some of the issues that on the trails that you can have definitely it's going to be pedestrian level lighting, so it's going to be lower level lights. One of the issues that it's going to be the light pollution from nearby areas. We have some trails that go behind homes, and sometimes people don't like it. Other times people love to have the light there just so that they can see what's going on in the back area. Vandal resistance are there. You're not going to need the lighting levels on a trail than you would at a street crossing, because you don't have that conflict between automobile vehicles and pedestrians on a trail where automobiles are not there. But the trails offers more opportunities for adaptive lights to either have less lights during the evenings and the very early morning hours, or to have a system using LEDs that provides the light to come on as the pedestrian is detected, and using solar power, which means that you don't have to, many times just providing power to an area is one of the bigger costs. So that could be a solution for especially remote areas where you'd like to have lit up, but you don't have the money to fund the power there, or where you've had vandalism with respect to power. That vandalism can occur with solar panels as well, but it's less likely to occur than it is where people who at one time when the copper went very high, they were in some of our parks taking out the copper wiring. And I know that our crews at the signal shop then worked and helped to convert some of the lights to LED lights to eliminate some of the copper theft issues that were going on.
In terms of solar panels, Mikey, is that a direction you're seeing a lot of cities going in? Is using a lot of solar power to generate some of their lights in downtown areas? Does that make things more flexible in terms of placing lights and things like that?
Well, I think you'll see that more in the rural areas where there's not a power source. If you have a convenient power source, you don't have with the direct power, you'll see less need for battery backups, things like that. But I think in the rural areas where there isn't a convenient power hookup, or where it's very expensive to extend power, solar lighting might be a solution. I don't see the every application having solar power onto it.
And Mike, I wonder if you would be able to navigate back to, I think it's slide number 38, where it shows two overhead diagrams of intersections, one with a traditional lighting layout and one with there it is. Yep. So there was a question about this slide. The person pointed out that comparing left to right, in the right situation on the right, it seems that the illumination is better for vehicles that are approaching the intersection, but they're concerned that after going through the turn, that the lighting might drop off as they're coming around the turn, where the lighting may be lower based on where these are placed. Is that a concern with this, as opposed to the more uniform distribution of light in the left-hand example?
Well, I think that again, the pedestrians in the crosswalk are backlit, and so they're not as well seen as they are in the other cases. But you're talking about the case where there are turning cars. Turning cars are going much slower than the high-speed cars that may be approaching it. So I think it's more important to do that. Plus, when you get wider intersections, wouldn't be surprised to see 8 lights illuminating the intersection, having lights coming on both sides, so that you have a more even light distribution. These are very simplistic, small intersection designs. When you have like 3 lanes in each direction plus dual left turn lanes, you're going to see a wider area. But the intent is to provide light on the front of the pedestrian as a higher speed vehicle is approaching the intersection. Whereas in the example on the right, if you're talking about a turning vehicle, well, the concept is that's supposed to light the area up, and they're already going at a slower speed where they can see and detect the vehicle. The vehicle headlights can work better. When you get to higher speed conditions, the vehicle headlights stop working.
Yeah, I think that was the concern with that right turn, as well as possibly the left turn conflict. The same kind of thing where you're, in the diagram at least, it's showing the light on one side, and that those turning movements might be at the darker side of the road. It's hard to say. Like, you're right, Mike. With the narrow road, it might work, but as it gets wider, I guess you're thinking more about lighting on all lanes, all legs, multiple lights per corner kind of thing.
And I know that the standard design from when I had left is now to put 2 lights per corner. In some cases, the lights come with a 2-light head, where you're lighting both sides, and strategically place it when possible, so that you're lighting the approach side for the crosswalks. It's not always possible, but when you can do it this way, as opposed to the backlighting, because just the pedestrian will stand out better.
Yeah, absolutely. I agree. I think with so many movements at these intersections, you're going to have sort of the front lighting in some conditions, but backlighting in others. So yeah, I agree. It's very complex. Mike, you did our presentation not long ago on the rapid flashing beacon, and so there have been questions that have been coming in about the rapid flashing beacon. At an uncontrolled crosswalk in a nighttime condition, is there cause for concern with the strobing pattern from that beacon sort of eclipsing, I guess, or sort of hiding the pedestrian from the driver's view if there's not a lot of other supplemental lighting at that crosswalk? Does that make sense?
Yeah, that does make sense, and that is a concern, because while there were minimum lighting levels required for the flasher on the rectangular rapid flash beacons, there really was no maximum level, and there can be such a thing as having too much light. In other words, distracting from the sign and distracting from the pedestrian. And the research that was that's been recently completed, I don't think it's been published yet, from Texas Transportation Institute. In fact, I've got a review of a working report, or the final report, that by a week from, well, by the next Monday. It should provide some of the information in there about that. So that was a consideration. And when I heard Kay Fitzpatrick, who's doing the research, saying that there is a sweet spot for the amount of light level, and the amount of light at night should possibly be less than the amount of light that's provided during the daytime, because during the daytime you're fighting with the sunlight, especially in the desert Southwest, where 75% of our days are sunless. Compared at nighttime, that light could be so strong it could make it more difficult or more distracting, and make it more difficult to see the pedestrian.
And that's not something, like you talked about the adaptive lighting, you're not looking at any kind of adaptation on your RFB brightness, I guess, based on time of day. It's a uniform. That's a uniform setting. Well,
there's a talk about having the lighting change versus day versus night. I don't, I'd have to look at what the report had said, but I do think that they're talking about different lighting levels. I'm having a minimum or a brighter level during the daytime. I don't know that that's a part of the existing systems. I know that when the research began a couple of years ago, they looked at a couple of different systems from different manufacturers and found that their lighting levels were below the minimum level, and they weren't getting as good driver response. During the research, they had the ability to change the lighting level of the flasher and the RFB to take a look at what effect it had on drivers, and that was studied as a part of the research.
Okay. Mike, if you could go 4 slides earlier in your presentation where you have a similar diagram but for a uncontrolled mid-block crosswalk. I think it might be
the wrong way.
You're getting
there you go.
Thing. Yeah. So when you're doing a rapid flashing beacon installation, I mean, you still want to kind of mimic this sort of pattern at that same crosswalk. Is that correct? Or you're not using the rapid flashing beacon itself as a substitute for lighting for the pedestrian?
No, the rapid flash beacon is not a substitute for lighting. It is a warning for the drivers. And the other issue with rapid flash beacons, if it's push button operated, there's some pedestrians who don't push the buttons. And we've actually gone to, as a part of our doing the designing for pedestrian safety workshops, we've gone to a location where they had to go from a push button operation for the rectangular rapid flash beacon to an automated detector, because there was such a high incidence of pedestrians not using the push button. So but that's not lighting up to illuminate the pedestrian. That's just to let you know that the driver know that there is a crosswalk in the area, and the actual visibility of the pedestrian is provided by the adjacent streetlights.
Mm-hmm. Okay. Mike, the agencies maybe when they try to deploy more, pedestrian level lighting, bollards, other things like this, to help improve safety for pedestrians, they may get arguments back against that from the perspective of not wanting to increase the amount of fixed objects in the roadside, or maybe the clear zone area. Can you speak to that sort of argument against maybe more lighting, and if so, what can be done? Can you look at things like breakaway poles or other things to help bring in the lighting without it becoming a massive increase in these fixed objects as a hazard for drivers?
Yeah, I know that in a number of our areas, or a number of our pedestrian level lights have actually put on the back of some of the street light poles, so that they're using the same pole but having a tall light on one going out over the street with a mast arm, and then a shorter light over the sidewalk area. The pedestrian level lights are typically further back from the roadway, so that's not as big of an issue in terms of drivers, run off the road drivers. In addition, they're typically more often used in lower speed areas, the downtown areas. It's not that much of an issue for motorists running off the road or hitting them or creating extra obstacles for motorists. There is a need, though, to make sure that there is a continuous pedestrian path, and that should have been discussed in one of the other webinars, so that there is a coordination of where the poles are placed, that you're not blocking a walking area or creating a slalom course for pedestrians. We talk about the zone system for pedestrian walkways.
Right. Yeah, and we didn't show any examples of that today on this webinar, but I think there are plenty of examples of where utilities have placed the light poles, right in the middle of the sidewalks, and creating those kinds of barriers and obstacles. And that coordination, I think, that's another one where you can see a lot of examples of where it's not been done.
Yeah, I noticed that when I had come back, when I arrived in Phoenix in '85, I saw a document that was authored in '74, and that's when they were just doing the coordination of the utilities with roadway projects. And that's if the projects that were designed prior to that publication. Many of the lights were the fire hydrants and everything else were put in. Were not coordinated with the sidewalks. And we talked earlier about coordinating the vegetation or landscaping with the lights. The utilities, I think that many agencies are doing a better job now, but we're suffering the sins from our predecessors or our fathers who have designed a lot of the roadways without taking that into account. And in fact, there was one sidewalk area where we actually had 2 irrigation structures. They were 3 foot by 3 foot in the middle of a 5 foot wide sidewalk. And we basically had to go back and modify the sidewalk to go around them because it was too expensive to move those. But it was something that was built in the 1970s when they had not given that a lot of thought. I think a lot more thought goes into newer roadway designs. But just like you coordinate the other utilities, you have to coordinate the pole placement. Combining any kind of poles or lights on existing wood poles or power poles is one way to cut down on the number of poles.
Mm-hmm. Okay. Interesting. Mike, there's some questions about if you're not using pedestrian level lighting and you're kind of relying on your street lights to provide your lighting, is there an issue with using sort of these traditional street lights that are coming on at a certain time of day throughout the entire year, the same time of day, even not considering when when maybe daylight savings time is coming around and things like that? And are there examples of how that can be adjusted throughout the year to make sure the lights are coming on and going off at the correct times?
Most street light systems that I know of, I don't know of any that are, I don't know of on a time of day basis. I know they're typically on, and there may be some, I just don't know of them. They're either individual photocells or on a system, a single photocell that may create or control a number of streetlights, so that it's based on the actual lighting levels that are out there. If you have a bad storm in the middle of the day, it might cause the streetlights to come on during the middle of the day to provide the extra lighting, where there's a lot of clouds and just, or if there's a situation where there's the darkness comes earlier because of cloud cover. So it's the photocells that are typically done on that. I'm not aware of a system that has a time of day clock that controls lights. Again, there might be some out there, and there may be some people that can write in and talk about some of the issues with that. I have my own thoughts on daylight savings time. I come from the only state now that doesn't go on daylight savings time, and I'm waiting for the rest of the country now to join us so that we don't have to keep changing clocks.
All right. That's a different webinar, I guess.
Right.
Mike, we had a session just last week on safety issues, pedestrian safety issues at interchanges, and during the discussion, this was an issue that was raised, is that interchange locations, you talked about pedestrian underpasses, but interchange locations are often areas where pedestrian lighting is not pedestrian facilities in general are not a consideration, but lighting especially can be blocked by an overpass, or the issue of drivers going under an underpass, even during the day where it can be very dark, and then coming out into a bright condition, and that kind of contrast there can be a safety hazard for visibility and otherwise for pedestrians. I wonder if you have any comments on how to maybe place lighting at interchange locations and some things to consider when doing so.
Yeah, that is a big concern, and you have long underpasses where the pedestrian is going alongside a roadway where you probably have to provide day and nighttime lighting. Tunnels too may have to provide daytime and nighttime lighting depending on the length of the tunnel, not only for the visibility and safety of the pedestrian, but also for security concerns. But making sure that there's a uniformity of lighting, and that the lights are lighting the sidewalk area before the pedestrian enters the roadway. And as I said earlier about maintaining lights, there's one of the biggest problems that I see around is the maintenance levels for lights and the lack of maintenance abilities, which makes the LED lights much more attractive. If agencies are continuing to lose staff. And I was at a meeting with my old division and found out that my division lost, I think was it 7 more or 12 more positions during the last year. If there's less people to maintain things, then they have to look at devices that last a longer period of time. But that is a big concern. Pedestrians are going to be at interchanges because that's the only place they can cross. So they should be expected. And just because they aren't there now, when you build an interchange or upgrade an interchange, somebody may come there in the near future, so that they should be designed to accommodate pedestrian crossings.
Yep, absolutely. One final question, Mike, and then we'll close up the discussion today. Can you speak to any recommendations you would have for agencies who are conducting audits, field audits, road safety audits, and the need, excuse me, the need to do observations during low light or nighttime conditions? I think you've seen a lot of examples of where agencies are doing audits and field investigation. They're probably typically doing that during the daytime hours, and I think that based on what you presented here, it seems that a lot can be learned by looking at conditions in nighttime.
Yeah, I've not been on a road safety assessment where we haven't done a nighttime inspection as a part of that. And same thing with you're doing school assessments. Many times, I had mentioned earlier, during the earlier years, many schools were built without streetlights in front of them to save on costs. They were looking at agencies, they were looking at the initial cost and not what happens later on. So school assessments should include what's going on at night. Even if lights are there at night, is the lighting levels good enough? So there should be an inspection of what's happening at night. Any type of a problem that's occurring at night, if you have a crash problem that's occurring at night, a nighttime inspection should be done. You'll see things differently at night than you do see during daytime. So that my old staff would, during the winter months, would take one person and offset their time in the office so that cover the nighttime hours to include nighttime visual inspections along the streets, so that they can have a monitoring of what's going on. That not only looked at lighting, but signs that are no longer reflective. Other issues that may occur at night that you wouldn't see during the daytime. Signs that are not reflective look perfectly during the daytime, but they may have nothing, no visibility. Lights that are not working, internally illuminated street name signs that we have at our traffic signal poles that are not working. And those need to be reported. And as I said earlier, it's important for agencies to have these mechanisms to either websites, phone numbers, or the apps that I'm seeing right now, where people can report in all kinds of problems, including streetlights, and then having someone at the agency end be able to respond to and address that and make sure that there is follow-up. So just having a site and a phone number is not enough. You need to have someone that's monitoring it and following up when something comes in.
Thanks so much, Mike. I appreciate the answer to that and all the other questions that we had today. Unfortunately, that is all the time that we have for discussion this afternoon. I'm sorry if we didn't get to your question. I would encourage you to please email us. You'll get our email addresses, webinars@hsrc.unc.edu. You can send us a message there, and we'll make sure we can respond to it. I would also encourage you to take a look at some of the slides that Mike put together. Again, we put these up on the website. We'll email you the link to that. There are a lot of good links and other resources that you can dive into from here, so I'd encourage you to take a look at all that. Once again, I just want to remind everybody that you will be receiving an email later today, this afternoon, with a link to the archive page for this webinar, as well as instructions for downloading your certificate of attendance. And so the archive page for the webinar already has a PDF copy of the slides from today's presentation. It will also, within 1 to 2 weeks, have the video recording posted from this presentation today. I wanted to let you all know that a very brief survey will appear once the webinar has ended. We would really appreciate your feedback and your comments on today's presentation. I want to say thank you again to Mike Sinecki for delivering today's presentation, and thanks to all of you for attending today's PBIC webinar. And I hope you all have a great day.